Hi everyone, this is the GAS walkthrough for February 6th. I'm Philip Newman, and today I'm solving Twin Detector Sudoku by Bill Murphy. We have normal Sudoku rules, 1 to 9 in each row, column, and 3 by 3 box. Additionally, we have some arrows in the grid. And what do these arrows tell us? Bill gave us an example, so we'll use that. This 4 has arrows pointing this way, and this way. And the example that he gave is focused on the arrow pointing up. So the digit in the cell with the arrow is the sum of some set of digits going away from the arrow. So either this single cell sums to 4, these 2 cells sum to 4, these 3 cells sum to 4, in the case of this up arrow. For the 9, this sums to 9, or these sum to 9, etc. So those are the rules, and Bill has fortunately given us a lot of short arrows to work with. So anywhere we have an arrow pointing at just a single cell, that just has to be a repeated digit. So that's a 2, that's an 8, that's a 5, that's a 9, that's a 3 that I missed, that's a 6, 7, and a 4. Now, some of them are restricted by just the sum being so small. So this 2 going this way can't be a single 2 because we already have it in a box. So it must be 1, 1. That's the only other possibility. This 4 going up, we said this cell could be a 4, but it's in the same column. These 2 can sum to 4. 3 cell summing to 4 is too big. Never mind that we have a 2 in the box, so it's even bigger. So the only possibility here is 2 cells, and the only way to do that is 3, 1. We could do 2, 2 on a diagonal, but we don't have a diagonal here, and there's a 2 in the box. Alright, the 5 is also going to have to be 2 cells. Can't be a single cell with a 5. 3 cells, the minimum is 6. So that's too big. So these sum to 5, we've got some possibilities there. This 4 can't be 2, 2. Can't be a single 4. So this also has to be 1, 3, I believe. Yeah, the other possibility here, because these are all in different boxes, we could have something like 1, 2, 1, but that's ruled out by the 1, 2 here. This must be 3, and this must be 1. Alright. This 8 can't be 3, 5. Can't be a single 8, obviously. So it's either... Actually, it can't be 2, 6 either. So it must be 7, 1 in this order because of this 1. The 9 can't be a single cell 9, so this must be 2 cells. 3 cells includes this 9, and that's too big. Lots of ways to make 9. We can rule out 4, 5 because they both see that cell. And this is going to have to be small. 2 and 7 both see this cell. So this is either 6 or 8, this is 1 or 3, and there's a 3 up here. So 3 and 6 see that cell. So that means 1 and 8 is our only possibility for that 9. That's a little mathy, but you can figure it out if you think about the possibilities. This is now restricted because we have this 1 up here. So the only possibility for 2 cells containing 5 is 2, 3. And going this way, the only possibility is 1, 4 because of this 3. And we know the order of that. And unless I'm missing something, this is the last one that we haven't done. It can't be 1, 6 or 3, 4, so it must be 2, 5. So that's all the arrows done apart from resolving these pairs. So now we're mostly just doing classic. And this has to be 6. And then I saw the 8s here. This has to be 8. 7's in one of those. Sevens must be here somewhere. 4 goes here. From those 4s and that 4. 9 in this box must go there. These are 1, 3, and 8. Not quite enough yet. 269. For 5, 6, 4, and 8. Yeah, that's not it. I'm missing something obvious here. Alright, so 5, 6, 7 there. 2, 3, 8. I have solved this before, but pretty much every time I test Bill's puzzles, I forget by the time I record what I'm doing. I think I'm usually slower when I'm solving on camera. Yeah, so this column needs a 4. There's a 4 there, so that's 4. 8, let's go here. So these are also 5, 6, 7. That gives us a triple here. So this is 2 or 3, this is 5 or 7. And we know where all our 2's are down here, just not what order they go in. These can't be 2. We've got a 2 there somewhere, and we've got a 2 there, so this is 2. And that's going to resolve the 6, 9 pair there. 5 and 8 in this column. 2, 3, 5. And do the 2. These were 1, 3, 8. Not resolved. This must be 5 now, though. Oh, I broke something. That 5 is wrong at the top. There. Not 5 and 8. 8 and 9. Not too bad of a rewind. That's 2. This is 3, 5. That was okay. 8's in this one. That puts 8 in this one. That makes that a 1, 3 pair. Which means that's 5. That's 3. That's 5, 7. 6 there. 4 there. 5 and 6 over here are resolved. And 2 and 9. 1, 3, 7 here. 4, 6, and 9. That's got to be the 9. 9's everywhere. In fact, we've probably got all of our 9's. Yep. So 4 and 6 are resolved by the 6. 1 and 7 here. Makes that a 3. This is not 5. This is not 6. So, oop. What did I just do? Oh, I already have 6 there. Huh. Not my best solve. This is 4 then. And this is 7, 5, 6, 7, and 5, and 7, 5, and 7, 5, and 6. And now we should be able to finish this off. Somewhere. There's a 5, so 2, 5 there, 3, 2, 3, 2, and then the 7 in the bottom. And that is the solution with the 3 in the corner. Finish. I like this variant. I think there's a lot of interesting things you can do with it. You can force particular number of cells on the arrows pretty easily. And because they can go in any direction and outside of boxes, you can have repeats, and we have the 1's here. Lots of interesting stuff you can do. So, I hope you enjoyed that. Let us know how you did in the comments, and I will see you next time.